Test tomorrow.
We could have a quiz tomorrow because you already know this stuff. Here we go. 2C. Directions say solve elimination.
Yeah, we'll try that out.
Alright, so last time we were together, we did some substitution problems, we did a couple of elimination problems. In elimination, remember the idea is we're going to add and something's going to cancel. So to make that happen, maybe we could do what?
Multiply the top by negative 2.
Multiply the top by actually.
2. Oh yeah.
Wouldn't I get rid of the whole thing?
Well, let's see, Michael. I don't know what your original intent was, but if it was to cancel out the x's, you accomplished that. But you also canceled out the y's, and you also canceled out the constants. So you end up with nothing on the left and nothing on the right. Last time we were together, we had a situation similar to this, but it ended up like this, something like that. These are very different. 0 equals 7 is never true, right? So this means the lines don't intersect. There was no intersection. Whatever your shapes were, they weren't intersecting. If they were lines, they were parallel. Here, this is not that. Here, 0 always equals 0. So what does that mean about these two equations? They're on top of each other. They're the same line. If you were to graph this one in pink and this one in orange, they would be right on top of each other. They're the same line. Okay? Everybody see the difference there? All right. Number 3, solve. It doesn't tell me how. So what is your thought? I can use substitution or elimination. What is your thought on this? Write small. This is going to be a lot of arithmetic, I think. Well, I can't really eliminate, so I'm going to have to substitute. And one thing I could do is say x equals 300 over y. Now, I'm not saying that's the only thing, but is that something I could do? Yeah. So if x equals 300 over y, then 2 times 300 over y plus 2y equals 100. Right? So let's see, I've got 600 over y. Remember, this is 2 over 1. So when I multiply, it's 600 over y plus 2y equals 100. What do you think I should do now? That's not good. What do you think I ought to do? Yeah, exactly, Melvin. So I'm going to have 600 plus 2y squared equals 100y. Okay, now what? What kind of equation is that?
Could be a
It not could be, it is
yeah,
like
I
that.
mean, you got
So let's get it set equal to 0. So I did some rearranging. Take a look at that and make sure you're good with that rearranging. And if you want to, we could divide everything by 2. And that would make our numbers a little bit
easier.
smaller. don't see it. I'm not saying it doesn't factor, I'm saying I don't see the factoring. So what? What do I do? Kids, not every problem is as easy as the first one you did. Okay? Substitution happens in more complicated problems. So here we go, y equals 50 plus or minus the square root of 2500 minus 4 times a times c
I forgot that.
all over 2a. Well, you need to remember it. So 50 plus or minus, what is that? Is that 1300?
Yeah, doing, yeah.
Can I do anything with the square root of 1300? Isn't it 13 times 100?
Yeah.
So
10,
10,
10, 13.
13,
Sorry.
and then I can cancel a 2 out of everything. So there are my y's.
Yeah.
We gotta be tough, folks. Doesn't always work out to be whole numbers.
Gotta do the arrow trick.
Alright, everybody with me so far? You got my y's? Now, how do I get my x's? Once I have my y's, I get my x's by plugging back in. And I'm gonna plug them back in this equation, which I divided everything by 2, and I got it looking like this now. Right? So, x plus 25 plus 5 root 13 equals 50. X plus this y value equals 50. So won't x be 25 minus 5 root 13? If I subtract 25 and subtract 5 root 13, isn't that the x that I get? And then I'm gonna do the same thing with this one, so it's gonna be x plus 25 minus 5 root 13 equals 50. Won't that be 25 plus 5 root 13? If I subtract 25 and add 5 root 13? Okay? Purpose of this chapter is to solve systems of equations and inequalities, and we've practiced the 2 ways that you already know: elimination and substitution. Now we're going to start talking about some other ways, but before we do that, we have to get some vocabulary under our belt, because we're going to start using matrices to solve these systems. So, section 7.1 is due on, when did I say?
It's gotta be Wednesday.
Wednesday?
Because we just finished.
I thought I signed it already. Maybe I didn't.
I remember that.
I just see things in our schools.
Doesn't say anything. Right, then I'm assigning it now.
Oh, I know,
It's
yeah.
so good. It's so good.
I know.
You're so
Yeah.
online.
So I'm assigning it today, and it'll be due on Wednesday. Okay? All right, 7-1, due on Wednesday.
Corn mango.
All right, vocabulary. Matrix. Anybody know what a matrix is?
Yeah, like when you get stuck in the matrix.
It's like in the government.
Like the Illuminati and all that. Like Bohemian Grove.
A matrix is a rectangular array of numbers
Oh yeah, that's what I meant.
arranged in rows and columns.
That's all.
So let me give you an example. That's the definition. All right, that is the definition of a matrix. But now let me give you an example. I'm going to call it matrix A. A rectangular array of numbers arranged in rows and columns. This is an example. Here are your numbers. They're in rows and columns. Now, it's really important, it's so simple, but it's so important that we keep straight what are rows and what are columns. If you walk into the gym, these are the rows of the bleachers, right? They go like this. These are the rows of the matrix. So this matrix has 2 rows. These are the columns, like the columns of the White House. These are the columns. So this matrix has 2 rows and 3 columns. Therefore, his dimensions, sometimes called his order, the dimensions 2 by 3, rows by columns. So the dimensions of a matrix are rows by columns. That's not times, that's by. Like a 2 by 4 that you buy at the lumberyard. This is a 2 by 3 matrix. Rows, columns. Rows come first, always. Okay? If a matrix is square, that should be an X, not a C. If a matrix is square, what do you think that means?
It's not a matrix.
What does it mean to be a square? What would be the same? The same number of rows as columns. So it would be like a 2 by 2, right? Or a 5 by 5. So a square matrix has the same number of rows as columns. Entries, or elements, are the numbers inside the matrix. Remember, matrices are a rectangular array of numbers. Those are called entries, or elements. If I want to talk about, for some reason, I'm having a conversation with somebody, and I want to talk about this number right here, I would denote it like this. What do you think this means? Row 1, column 3. So I'm looking in matrix A, lowercase, directs me to matrix A, first row, third column. So what would this be? What is A sub 2-1?
So A would equal 2. Sorry, 5.
Bro, what?
-1.
-1. Second row, first column. Always, 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 in matrix land, The first number refers to rows, the second number refers to columns, always. A scalar. You guys in physics, what's a scalar?
Are we skipping this?
I'll do the next chapter.
A scalar is simply a real number. A scalar is a real number. It has no magnitude, it's just a number. It's just a number. Equal matrices. Anybody want to take a wild guess? What do we mean by equal matrices?
Two matrices that are the same.
Okay, so what does that mean?
Same numbers inside the.
Okay,
The
let's
same
talk about
number
that.
of rows and columns as well
So,
as numbers
okay,
inside
okay,
the rows.
so I like that. They have the same dimensions, same number of rows and columns, so they're both 2 by 3 or something. And then you gotta be careful about this because they have the same entries. But I gotta be careful because these two matrices have the same dimensions
But not
and the same entries. I have to add something.
The same location.
Same place, yeah. So the same entries in the same spot.
It's literally just one that's the exact same.
You'll see why that's useful though, that definition.
Alright.
Same corresponding entries. The corresponding entries are the same. So the 1 spot, the 2 spot, all of those are the same. There are lots of, oh gosh, lots of things you can do with matrices. A couple of the big ones are the transpose. The transpose is denoted with a superscript T, like an exponent type T. I like to use uppercase, but sometimes you'll see that as a lowercase t. So anytime you have a t up there as an exponent, looks like an exponent, you're doing a transpose. And here's the transpose of this matrix. Can anybody tell me, how do you build the transpose?
The rows and columns are switched.
You switch the rows and columns, that's right. You interchange the rows and the columns. And that's something that we do actually in various matrix operations. We switch the rows and the columns. Remember, you can take an entire semester college class called linear algebra, which is matrix stuff. So we're just barely scratching the surface. Okay, and then the trace. So I'll just say the trace of matrix A. That would be denoted like this. Trace and transpose are very similar words. So remember that transpose is like the exponent type thing. Trace has a little TR out in front of it. If this is matrix A, there is no no trace. Because if you're going to find a trace, your matrix must be square. This is not a square matrix, so therefore I cannot find its trace. So let me put a square matrix up here. The trace is a number. Someone might guess it. Kind of hard to figure it out. I've never done it before. It's easy to calculate. Anybody have any idea where I got that 7? this is called the main diagonal of the matrix. And what happens if I add up those numbers?
You get
I
7.
get 7. So how do we get the trace?
The main
We
diagonal.
add, to get the trace, we add the 1, 1 spot, the 2, 2 spot, the 3, 3 spot, and so on. This is first row, first column, second row, second column, third row, third column, and however big it is, you just keep going. The entries on the main. All right, let's do some problems. Here we go. Number 2, here's a whole bunch of matrices, and we are going to do something. All right, A plus B. Take a wild guess and you'll be right. What do you think's gonna go right here?
7.
Yep, I told you, you are right. What's gonna go here? 1. What's gonna go here? And, there you go. How do we add matrices? Add corresponding entries. Now, what does that automatically imply? If you're gonna add them, they have to be the same size. Because they gotta have matching entries to add. So if they do not have the same dimensions, you can't add them. They don't need to be square, they just need to match. All right, A plus 2B. Here's A. What do you think 2B is? So 12, 6, 0, negative 8? 2B? 2 is called a scalar. When you multiply scalar times a matrix, it's like a big distributive problem. So what would the answer be? We're adding these. Adding, yep. So what would the answer be? 14, 4, 3, negative 3. How's that work? Jimmy, you with me?
I already did it.
You already did it. All right, do you see 2A plus B? Eli just can't do it. Why can't we do it? They're not the same size. They're not addable. They are not addable if they're not the same size. A subtraction, same thing. Add and subtract work the same way. All right, next problem. Hold on to your hats. Matrix multiplication is interesting. First of all, when we multiply, they do not have to be the same size. What they have to have is this. This matrix is a 2 by 2. This one is a 2 by 2. If you're gonna multiply, these two numbers must match. So you could have a 3 by 5 and a 5 by 8, and you can multiply this. As long as these two match, you can multiply. These tell me how big my answer will be. So, this answer is going to be another 2 by 2. So the insides match, and the outsides tell me how big my matrix is. So I have 4 numbers to figure out. Ready? To find this number right here, Notice that this number is in the first row and the first column. So we're gonna multiply the first row of numbers times the first column of numbers. So remember I told you earlier, everything is rows first. Rows times columns. So I like to write down my row numbers, there they are, 1, and 2. Then I match them up with my column numbers. So 1, -2, 6, 0. I multiply each pair and add them together. So the number that goes in this spot right here is 6. Now when I move over here, I'm gonna do exactly the same thing. Only now I'm gonna multiply row 1 times column 2. So row 1, column 2. Multiply each pair and add them up. So it looks like that number is 11. What are you doing? Stop it. Okay. Any guesses as to what I'm gonna do here?
Row 2,
Row
column 1.
2, column 1, all right, go ahead and do it. Numbers in row 2 times the numbers in column 1. Multiply each set and add them up. What'd you come up with? You got it. What you got? Yeah. So 3, 5 times 6, 0, that's 18. And then the last one will be row 2, column 2. You already got that one?
-11.
-1. Now, next problem says take D times C. Can I do this problem? Can I multiply these two matrices together? What are the dimensions here? 2 by 3. Rows first. 2 by 3. What are the dimensions here? 3 by 3. I can multiply, and my answer will be another 2 by 3. Now, this is going to work the same way, it's just bigger. So to fill this, we'll take row 1 times column 1. There's a lot to keep track of. So 2, -1, 3, that's row 1. And then column 1, 1, 0, 1. Now some of you can do that in your head. Some of you might want to write it down. I think we get 5 for that one, don't we? It's easy to make careless errors, so watch it. All right, go ahead and fill in the rest of them. Let's see what you come up with. If it's an emergency. Oh, you can pass.
Correct.
Telephone.
You got your number 0? Okay, put them up there for us.
That you saw my head.
It's all right, just put them down, we'll see if we agree or disagree.
Okay.
Whoa.
It's all mental math.
It's all right, if you're wrong, we'll just laugh and move on.
That's not what I got.
I think part of it's okay,
I got
right?
2 of them.
Which ones do we disagree with?
6 and
Yeah,
18.
yeah, I'm not sure about these. Darn it. So that would be row 1, column 3.
4, 2. Oh, it's 5.
Wait,
Yeah, that should be 5.
I got -1 times -2.
And then what's this? This is row 2. And column
So,
2.
-5, 3, and 4, 8.
How's 14 sound? Anybody else have a question about one of those numbers? You okay with that? Yeah,
So why would it be a 2 by 3?
remember, when you go to multiply matrices, the inside dimensions have to match. The outside dimensions tell you how big it is. All right, how about F? A times C? Can't do it because A's a 2 by 2, C's a 3 by 3, and the dimensions don't match. The inside dimensions don't match. Royce, you got that?
Yeah.
Okay. All right, E. One more multiplication problem. A transpose. What does A transpose mean? Switch them. Switch them. So A transpose will look like this. What was row 1 is now column 1, and row 2 is column 2. So that is a transpose, and we're gonna multiply it. Oops. We're gonna multiply it times B. 6, 3. All right, got a 2 by 2 and a 2 by 2. And end up with a 2 by 2. Here we go. I'll show you what I get. You tell me if I'm right or not. It's so easy to make mistakes. How do those numbers look? Did I do okay? This is wrong?
Why is it?
That is row 1, column 2. 3 minus 12. Row 1. How about the rest of them? Any others we need to talk about? We're okay with that? Okay, there's a quiz in your future, in which case you're gonna have to be able to do this. So are we good on these numbers? Everybody's okay? All right. Finn, do you need to go to the nurse, honey? Are you okay? You need to go down to the nurse?
I'm good.
Okay. All right. Matrix A. Notice that when I wrote it down, I did not use brackets. Brackets are the notation for a matrix. Straight lines that look like absolute value, that's the notation for what we call the determinant. Every square matrix gotta be square. What else has to be square? Trace. Trace and determinant have to be square. Every square matrix has what's called a determinant. To calculate the determinant, it's very, very easy. The value of this determinant would be 1 times 5 minus 3 times negative 2. So in other words, I multiply these guys and get 5. I multiply these guys and get negative 6. And then I subtract them. So 5 minus negative 6. So I'm multiplying on the diagonal, and subtracting. So the value of the determinant is 11. We can do this with every square matrix. So can you do B? What is the determinant for B? Be careful. Very common mistake. Negative 24. 0 times 3 is 0. So it'll be negative 24 minus 0. You okay with this? Determinant of C. Now, C is a little bit bigger. Quit acting like you're bored. This is fun stuff. Alright, so we're gonna find the determinant of C. Procedure is kind of the same, but a little bit different because it's bigger. So here's what you do. Everybody paying attention? Take the first 2 columns and write them down right next to the determinant. So 1, 0, 1, negative 1, 3, 4. Now, multiply these 3 numbers together. So what do I get when I multiply those? I get 0. Multiply these 3 together. total them up. So all of this just gave me 1. Now I'm gonna turn around and go the other way. So I'm gonna multiply these together. What do I get? 6. And then these, what do I get? -4. And then these,
0.
total them up, I got 2. Now remember when you did your 2 by 2, you multiplied, and got 5, you multiplied and got -6, and then you subtracted those 2 numbers. So guess what I'm gonna do with the 1 and the 2? I'm gonna subtract them. So the value of the determinant is -1. So it's all of this minus all of this. All right? How about K? The determinant of D. Who was paying attention? Can't do it, because if you're gonna do a determinant, it's gotta be square. Right. All right, number 3 is exactly like the one we just finished. So see if you can do problem 3. You're gonna find the determinant. Do I have a volunteer to come up and do it on the board? Or a team of volunteers? Thank you.
No, you want some help?
Yeah.
I'm so
Pay attention. We're gonna walk you through.
I was like,
I'm on time. I tried.
I don't know.
Our relays were so hurt, so just like figure out
I was just like,
when on race day.
yeah.
Just because I don't race day. I don't know go run although I can.
Wait,
Two laps up.
I said you would do it, and I forget how. Your gram negative 26, I don't want to do it.
No, but
This is row 2.
Yeah.
wait, St. Elmo's? St. Elmo's Starbucks. Yeah. St. Elmo's.
That's -6.
So you're, okay, so you're the top left one, you the top.
So you're grade
How would you get 106 and then?
Only by 4?
3.
Hook them up.
Your grandma's wife.
Yeah.
It's 11, my dad's wife is right.
1, 3,
My grandma's dad.
6. Yes.
Oh yeah, you're right. But it's just. Yeah, I'm looking at the way it's like. Well, that.
Yeah, I was about to say, what's up?
It looks like an 8.
Yeah.
All right, what'd you come up with? 104? That's what I got too. Anybody not get 104? One thing about this little unit is, everything is easy, but you have to remember the process. Gotta remember the process, but the work itself is very easy. Nicely done. You okay with that? Are you okay with that? All right. Now, we have one more thing to talk about today, and that is problem 4. Anybody know what that little -1 exponent-like thing means? It's not an exponent. It looks like an exponent. It's the inverse. All right? So matrix A is 1, -2, 3, 5. Pay attention.
So we just flip a sign on all of them?
No.
We get 2.
We're finding the multiplicative inverse, not the additive inverse. All right? So, 2 steps. Step 1. Find the determinant. So we're gonna find the determinant. So that's easy. 5 minus -6. I got 11.
I have a question.
Multiply, subtract. So 5 minus -6.
If you were going to do one of these, and it wasn't
So Michael's question was, what if we were trying to find an inverse of a matrix that's not square? You can't do it, because your first step is to find the determinant, and if you're not square, you can't find a determinant. So matrices that aren't square have no inverse. They're called non-invertible. You can't invert them. No inverse. All right, so step 1, we're finding the inverse. Step 1, determinant. Now, step 2, we're gonna build a new matrix.
The same.
Now, the name of it is called the adjoint. I'm never gonna ask you that, but just in case you want to know what it's called. We're gonna build the adjoint. To build the adjoint of a 2 by 2, you take these two numbers, look where I'm pointing, and you switch them. The other two numbers, positives become negative, and negatives become positive. So, these two switch places, these two become opposite, they change their signs. So that's a -3, or that's a +3, so it becomes a negative. That's a -2, so it becomes a positive. Yeah. Now, your inverse are these numbers over 11. So 5 11ths, 2 11ths, -3 11ths, and 1 11th. If your fractions reduce, you need to reduce them. Royce, why do I feel like you're not paying attention?
I was till like 2 minutes ago, but I got this.
Okay, well, let's lock that in. All right, one more, let's find B inverse. Repeat the steps.
Why would I ever?
And then I got,
find
I'm not gonna do this in the grocery store.
All right, what's step 1? We're not going there, these are brain exercises, these are our brain steps. Here we go. Find the determinant. What is the determinant of B? -24. Multiply, subtract. -24 minus 0. Now, build your adjoint, your new matrix. So these guys flip. Zero is just 0, but positive is going to become negative. Now I'm going to put all these over -24. I'm going to do it over here to the side because I'm going to have to do a bunch of reducing. So my first one will be 1/6, 1/8, 0, and -1/4. There is your inverse. Tomorrow we are going to be using our calculators extensively, so be sure yours is charged up and ready. Alright, tomorrow will be a big calculator. Homework 7-1 is due on Wednesday.
I already done my sections all the time. I would have been proactive.